Assalamualaikum and good morning to our panel, Sir Muhammad Fauzi bin Othman and Dr. Valliyappan anak lelaki Natarajan. And to all viewers, today I am Muhamad Hafizi would like to present my final year project. I undergo my FYP under Dr. Muhammad Afzan Muhammad Anuar Supervisor. The title given is Mechanics of ACL during Deep Squatting Motion. Okay, before I go through the presentation, I would like to brief the content in this presentation. First, we will go to project summary. Next is introduction, then literature review. In literature review, I will explain about ACL graph, biomechanics of knee joint during squat, and effect of ACL reconstruction on knee mechanics. Then, we have problem statement and objective. We also have scope and limitation of this study. Lastly is expected result. Project summary. This study is intended to investigate the impact of the ACL graph on knee mechanics during deep squatting following the ACL knee reconstruction. Zaidi software will be used to construct the 3D model of knee joint with different types of graph. Then, the finite element model and analysis for the 3D model of the knee joint will be implemented in Abacus software in order to replicate the knee motion during deep squatting motion. From the analysis, the effect of different graph reconstruction on the knee mechanics, which includes ACL stress and strain as well as stress distribution in cartilage, will be observed. Introduction. What is ACL? ACL is a short form for anterior cruciate ligament. It is a part of tissue that crosses in the middle of the knee. ACL connect the thigh bone, which known as femur, to shin bone, which known as a tibia in the knee. ACL is important to maintain the stability of the knee joint. Next is ACLR. ACLR is stand for ACL reconstruction. ACL reconstruction is a treatment where it changes the ruptured ACL with ACL graft. It is the standard surgical treatment in order to provide the stability. According to the previous study, there are almost 100,000 ACL reconstruction have been done annually in the United States. This is because the treatment is recommended by experts because the failure of the ACL to regenerate after the injury. Okay, for the literature review. First, we have ACL graft. ACL graft is a type of tissue which have been used to replace the broken ACL tissue. According to previous research, there are two main groups of graft which are autograft and allograft. There are many options for both graft depending on several requirements such as simple accessibility, low mobility of the donor site, immediate rigid fixation, and rapid wound healing that can replicate native ACL site to the limit. As we can see on the table at the right side, it shows the option of the autograft and allograft. Even though there are a lot of options when choosing type of graft, there is no consensus among the experts on the best grafting option to replace the injured ACL. Next point is biomechanics of knee joint during squat. Knee joint consists of tibiofemoral joint that assist by the patellofemoral joint. Usually, when it comes to the knee joint, exercise that related to it is squat exercise. This is because squatting exerts highest knee force as compared as walking, stairs climbing, and chair sitting. During squatting, the knee flexion of the person is 20 to 140 degree depending on the depth. Basically, squat does not cause damage to the safe ACL as the ACL failure load range is much higher than the peak of the anterior shear strength of the knee between 0 to 60 degree of the flexion of knee. The quadricep, hamstring, and gastrocnemius constitute roughly 98% of the cross-section area of the knee musculature. While do a squat exercise, hamstring muscle serve as concentric and eccentric hip flexor during lifting and lowering phase. Quadricep muscle are also used both eccentrically and concentrically during squat. Last point in literature review is effect of ACLR on knee mechanics. The first one is effect of ACLR on knee mechanics through clinical approaches. For the first study, they compare between HT autograft and BPTB autograft. There are two tests that they do to observe the effect of ACLR, which first is pivot shift test and second is Leishman test. And the result for the first test found that BPTB has significantly decreased risk of positive pivot shift test compared with HT, while for Leishman test there is no statistical difference found. For the second research, they compare between autograft and allograft by do arthrometer test. And the result found that statistically significant change in mean anterior knee laxity, with mean autograft laxity being 1.8 plus minus 0.1 and mean allograft being 1.4 plus minus 0.2. Next, in the third study, They compare QT autograph and BPTB autograph. They had run 3 tests, which are KT1000 autometer test, Leishman and pivot shift test. The result for KT1000 autometer test found QT graph have slightly lower percentage of knee with more than 3 mm side-to-side laxity compared to BPTB graph, while for Leishman and pivot test, there is no significant difference found. For the last research, they are comparing single bundle and double bundle graph by do autometer test. The result found that double bundle have 0.52 mm less anterior tibial translation than the single bundle. The second observation regarding to the effect of ACL on knee mechanics is by finite element analysis. Under finite element analysis, we have graft pretension. Graft pretension is a technique that can be used during ACLR in order to avoid loss of tension after surgery. It will be applied to soft tissue graft during the ACLR. This kind of technique is recommended when performing the ACLR to achieve the best retained tension in the graft after placement. For the first study, the type of graft that have been observed is hamstring tendon. The force exert is 20, 40 and 80 Newton. The result from the study shows that corresponding anterior-posterior translation was 2.1, 1.4 and 0.6 mm respectively. As a conclusion, the group with an initial tension of 80 Newton had a lower anterior laxity compared to group of 20 Newton. In the second research, the force used for the graft pretension is 0, 10, 20 and 30 Newton, and the result said that as far as the influence of graft pretension is concerned, no effect was found at 5 mm side in the posterior, anterior and posterior proximal sides. Last but not least, the last study do research on BPTB graft which was 0 and 40 Newton. As the result, the tibia has free movement apart from the direction of flexion while the femur fixed. Besides, the numerical result revealed that ACLR was successful because the anterior tibial translation was restored back to normal, thereby adding to the stabilization of knee. The next slide is about problem statement and objective of the study. For the problem statement, number 1, no consensus among experts regarding to the best type of graft for ACL reconstruction. Number 2, the stability achieved after replacement of ACL with ACL graft. The objective of the study is to construct the 3D model of knee joint. Besides, it is also to develop the finite element model of knee joint with different type of ACL reconstruction. And the last one is to observe the effect of different graft reconstruction on knee mechanics. Next, I will be explain about scope and limitation for this study. First scope of this study is focusing on finding the best common type of ACL graft, which are bone patellar tendon bone graft, quadricep tendon graft, hamstring graft and patellar tendon graft by observing the effect of the ACL graft on the knee mechanics. Then, it construct the 3D model of the knee joint with the different type of graft using CAD software. The finite element analysis for the 3D model also will be done using Abacus software. Other than that, the effect of graft will be analysed in deep squat motion state behavior, where during the state, the knee joint will face high tension and force. For the limitation, the knee joint model will be constructed from held knee model available in SIMTK website due to unavailability of C7 data of ACL rupture knee. Methodology. To achieve the objective of this study, there are few software will be used. For the construction of 3D model of knee joint, it will be done by using CAD software. And to run the analysis in order to get the finite element analysis, Abacus software will be used. The use of Abacus is to observe the effect of different graft reconstruction on knee mechanics during deep squat motion. As shown in flowchart below, first and foremost, we need to construct the 3D model of knee joint. Then, it will be developed to 3D finite element model. Next, we'll be doing assignment of major knee ligaments, bone and soft tissue material properties. After that, we will proceed with development of boundary condition and knee loading of deep knee squatting. Lastly, we will observe the analysis of ACL stress and strain on cartilage. Last but not least, at the end of the research, there will be effect on the ACL after the reconstruction of ACL, especially in squatting motion. Due to the high force exerted on the knee during squat, there must be limitation in tension, stress and strain that the ACL can withstand. In addition, all the information that include in the 3D model of knee joint produced in CAD software will significantly influence on result of simulation model. With the use of Abacus software, the finite element model analysis will then stimulate and observe the effect of different types of ACL graph during deep squat motion. I think that's all from me. I have done presenting my final year project. I hope you like it and thank you for watching.